So let's get to the final, or through the final leg of this series, and actually finish up with the Burp suite here. Actually, come to think of it, I don't think it's the final, but close to final, because there is also the Burp extender module. So the Burp extender shouldn't be too complicated, but we'll get down into it probably in the next video. Now we are actually focusing on the sequencer, and the lab or the machine is started. So sequencer task number 7, and as a reminder, so far in this series, so in this playlist, we have actually 39 videos. So from the beginning, principles of security, we went through iDoors. What's this inside the series? File inclusion, SSRF, XSS, command injection, SQL injection, and then we have 16, another one here. So we have 16, 17 videos on Burp Suite. Now this is going to be the 18th video here. Sequencer is one of those tools that rarely ever gets used in CTF and other lab environments. We're not interested in CTFs here. Okay, so, but it is an essential part of real-world web app penetration tests. In short, sequencer allows us to measure the entropy or randomness of tokens, strings that are used to identify something, and should in theory be generated in a cryptographically secure manner. We may wish to analyze the randomness of a session cookie or a cross-site request forgery token protecting a form submission. If it turns out that these tokens are not generally secure, then we can in theory predict the value of upcoming tokens. Just imagine the implication of this if the token in question is used for password reset. So it's actually being able to take over the account of someone. At least that's that's one of the first thing that comes to mind. But other than taking over individual accounts, you might be able to take over the entire application. For example, if you're taking over the account of an admin. Let's start as ever by taking a look at the sequencer interface. So we have the sequencer interface here. All right. There are two main methods we can use to perform token analysis with sequencer. You have the live capture, which is the more common of the two methods. This is the default for sequencer. So you have the live capture over here. Live capture allows us to pass a request to sequencer, which we know will create a token for us to analyze. For example, we may wish to pass a post request to a login endpoint into sequencer, as we know that the server will respond by giving us a cookie. Now with that request, we can tell sequencer to start a live capture. It will then make the same request thousands of times automatically. So this is really important to keep in mind. Storing the generated token samples for analysis. Once we have accumulated enough samples, we stop the sequencer and allow it to analyze the capture tokens. So in this situation, actually the sequencer will be able to tell whether or not this is a solid token or sample in terms of randomness or not, whether or not it can be predicted. And the manual load, so the second main method, allows us to load a list of pre-generated token samples straight into the sequencer for analysis. Now using manual load analysis, wait, so did I actually start recording? Yeah. Using manual load means we don't have to make thousands of requests to our target, which is both loud and resource intensive, but it does mean that we need to obtain a large list of pre-generated tokens. So this is often not the case. We will be focusing on live captures in this room. So familiarize yourself with the interface. Let's say that is completed. So we have the live capture here. This is where we are sending the request, for example. So we are in the proxy tab. Let's say that we send to sequencer from here, and it's going to be here, and then we can start the live caption. Now you have the token location within response. where do you actually want, where is the exact token location, for example, whether or not it's in a cookie. So if we send this also to the repeater, we can see if we don't actually have to send it to the repeater because you have the cookie here. So you have the session cookie, and in the sequencer, that's where you have, or in the form field login token, we go back here. There should be a form field. Where is it? Login token, which is over here. That one, which is hidden. That's probably the one that we're actually going to look after. Live capture options, of course. So this is what you have for the live capture. Then you have the manual load. And of course, this is where you paste all the thousands of requests that you have. And then also there's the analysis options, which allows you to actually be more sort of like granular with how you want your sequencer to run. All right, now live capture. The best way to learn is by doing. I 100% agree with that. We will start by capturing a request to this in the proxy and send to sequencer, which is what I did. So I'm connected to the THM VPN. My Burp is actually proxying stuff from Firefox, and I've captured this request. I've sent it to sequencer. It's in the sequencer. So what do we need to do next? Notice in the token location within response, we have the options to select. So as I've shown you, from form field and custom location. In this instance, we're testing the login token. So we're going to do the form field. All right. We can also set a custom location, of course. We can safely leave all other options at default. So let's go ahead and start live capture. And this is actually where tokens are generated. So this is really good when you're actually doing a penetration test and you're dealing with some sort of a field or a token or something that is randomly generated. You can actually do a sequencer analysis to actually determine whether or not the randomness is good and whether or not that token is actually strong. So, a new window will pop up telling us that we're performing a live capture. We need to wait until we have a reasonable number of tokens, that is around 10,000. So the more tokens we have, the more accurate our analysis. So let's see. Right now we have 2,000. We're actually going to wait until 10,000. We could also have chosen to stop the capture, however, by choosing to pause it. Instead, we leave the option to resume the capture open should the report not have enough samples to calculate the entropy of the token. So entropy is actually a measure of randomness, as far as I know. Entropy meaning. So in physics, entropy actually comes from physics, from thermodynamic. In physics, a thermodynamic quantity representing the unavailability of a system's thermal energy for conservation into mechanical work, often interpreted as the degree of disorder or randomness in the system. So entropy, the degree of randomness in the system. That's what we're actually doing here. If we wanted to receive periodic updates on the analysis, we could have checked auto analyze checkbox. So there's also the option to auto analyze here, which is not set. What else? Doing this would tell Burp to perform the entropy analysis every 2,000 requests or so, giving us frequently updates that will get progressively more accurate as more samples are loaded into the sequencer. So in this situation, the more the better. It is worth noting that at this point we could also choose to copy or save the capture tokens for further analysis later on, of course. So you can actually save these tokens, and then later on you would manually load them for manual analysis, of course. Having clicked the Analyze Now button, Burp will proceed to analyze the entropy of our token and generate a report. We will look through this in the next task. So follow the steps above, which is what we did. Try performing the capture again, but this time monitor your requests in Wireshark. So we're not going to do this. Can you see why live capture the request for this analysis can be described as loud? Probably because it generates a lot of network traffic. So let's see the status. We are at 8,000 and we have about 1,500 more to actually finish this. We could also do the conclusion here just to complete this room. Decoder, sequencer, and comparer is what we've actually been through in these few recent videos, and they may not be as well known as proxy, repeater, or intruder. They are still very useful. You should now be comfortable with them, so you should actually be quite comfortable with them after going through these videos in this series. Comparer to look for differences between two data sets, decoder to transform data, and sequencer to perform entropy analysis on tokens. This room has covered enough to give you the fundamentals. The next and final room is the extender, so we'll go into that in the next video. Now, task number 9, analysis. This is what we need to do. Now that we have a report for the entropy, it's time to analyze it. I think it's done, right? Yeah, so we can actually... What did they tell us to do? Once you have around 10,000 tokens, click pause and then select the Analyze Now. So we should click on pause, Analyze Now. Alright. Burp performs dozens of tests on the token samples that it captures. We won't be looking at all of these as it would take far more than a single test to do so. It's going to be math intensive. Instead, we will focus on the generated summary. However, you are encouraged to look through all of the test results for yourself. The generated summary entropy analysis report is split into 4 primary sections. So let's see. We have the summary, we have the character analysis, the bit level analysis, and the analysis options, of course. Now, the summary gives us an overall result. So the overall quality of randomness within the sample is estimated to be excellent. At a significance level of 1%, the amount of effective entropy is 112 bits. Alright, collectively these will often be enough to determine whether the token is generated safely or not. However, in some instances we may need to have a look at the test results directly, so you can do that by character level analysis, of course, and you have multiple details here. You can look at the summary, the count, the transition. Of course, I do not know much about these, and the character sets. As mentioned previously, we will not be going into these. In short, with an estimated 1% chance of being incorrectly based on the data provided, Burp has calculated that the effective entropy should be around 107, 112 in this instance. This is an excellent level of entropy to have in a secure token, although it should be noted that it is impossible to say with absolute assurance that this calculation is entirely accurate. Of course, because you're doing an analysis on something that is randomly generated, and to be very accurate when it comes to that is quite difficult. Take some time to look through the tests. You don't need to understand all of these, but it is important to know that they exist. So there's also the bit level analysis, which looks at significance levels. So if you come from statistics and also from physics, you would actually better understand them. So you should have knowledge in statistics, physics, and mathematics to actually be able to be very intimate with these results. You also have the effective entropy. And of course, if you look at the bit level analysis, there is a lot under the hood here. Not only the summary, but all other results here, and you also have the analysis options, which you can set or modify and then redo the analysis. But of course, a lot of people will just look at the overall results and read these two lines. Reliability, of course, on 11,137 tokens, token length 32. So yeah, that's what it is when it comes to sequencer. Very, very useful in penetration tests, as I've said previously. With that, we have actually completed the other modules room, and then next we're actually going to go into the extender tools. Really excited about this. Once we finish the extender tools, as I've said, we very likely are not going to go in through the others here. We may take a pause or maybe resume them at a later point. What we're actually going to do is we're going to look at hacksplaining.com and go through the lessons here, which is really important for application security. And of course, I may be resuming the other session with open application security verification standards. So there are a couple of more videos that I need to do in this series to actually go through the entire OWASP ASVS. The last video is from 1 month ago. So there's a lot of stuff to cover, so stay tuned for that.